All right, I'm going to share a theory with you. I'm calling it a theory because as much research as I've done, I haven't found anybody that could really explain why the planets are being able to stay where they're at. They say we're caught in a gravity well or something, but why are we not going into the sun? And I'm going to explain my theory on why the planets are not falling into the sun. So I'm going to start small and talk about the smallest particles. Everything, it's my understanding that everything that has matter, has its own gravity well. Okay? So space itself, massless object, dark matter or dark energy. I'm going to talk about dark matter and basically what I believe my term of dark energy is. Uh, so the gravity well of a mass, a piece of dust or whatever it may be that has mass, the gravity well is actually dark matter being pushed away from the object with mass. It's it's being pushed away from it. Okay, that's the gravity bubble is actually dark matter being pushed away from the object with mass. Um, and the amount that it's being pushed could be considered dark energy, I guess. I don't know who invented those words, but we can use them. So when you get two objects that come together with mass, the gravity well of each object is actually the dark matter that's being pushed away. When they come together, the gravity well will expand. Okay, and now here's the key thing: dark matter cannot be broken. It can only be stretched. Okay, it can't be broken. It can only be stretched, and it seems completely obvious to me, and we can see it out in our universe. We can see it. We can see it in small chemical elements, gold, silver, whatever. We know they have so many electrons, blah blah. How come those electrons don't collapse into the molecule itself? Because dark matter cannot be broken. And here's my explanation. It can only be stretched. So these lines, these dots represent objects of mass, okay? All these lines is just depicting the stretching of dark matter, okay? We call it dark energy or gravity tendons, whatever. These lines are just depicting what's happening to the dark matter. So when you get a lot of these, okay, your dark matter, your displacement of dark matter expands. Okay. Dark matter displacement. That's the one. Dark matter displacement gets larger with the addition, of more mass. So now I'm going to get into here now what happens when that dark matter displacement reaches a certain point. All the mass is close. All the mass is close to each other here. However, the dark matter can be stretched way out. Well, since all the mass is over here, even though the dark matter needs to account for the amount of lost space, it's weak. It's inside it. It's still there. You know, we see our sun and it's got to reach way out there. But it's a weak force. But inside, you get to a certain point and there's relax zones. The dark matter can actually relax and recollect itself. I believe it forms in a vortex-like shape, which would very easily account for how the planets are formed or how electrons are formed. Uh, the dark matter displacement is when it gets beyond a certain point, has a relax zone where a vortex is created. It's kind of a comfortable spot. It's a comfortable spot for more mass or matter to accumulate, way away from the center, way away from the center. Um, so hence, when a certain amount, a specific amount of mass is accumulated, an electron will be formed. When you get more mass, another electron will be formed. And I believe, I'm going to say this, that there are different size electrons. They're not all the same size. You're going to have bigger electrons, you're going to have smaller electrons. And if you just scale that up, you can see how the planets are formed. The sun's dark matter displacement will allow for vortexes, relaxing vortexes to be formed, for the reaccumulation of space inside itself. That's and because it's a vortex and because the mass is not moving, the vortex, the planets will never fall into the sun because the displacement of the dark matter is always consistent around the mass. So the displacement, if it's happening out here, that means this is the area where the dark matter can relax or the vortex can be created. It's the relax zone, okay? This isn't moving, isn't shrinking. The only way the planets may fall into the sun is if, gosh, I don't even know. The starts to break itself apart. Who knows? As it is, as what we know, as long as the sun's there, the planets are going to stay where they're at. It's the sun's dark matter displacement that's keeping the planets where they're at. Okay, why are the planets different sizes? It's because the amount of displacement that's happening is completely in symmetry with the amount of mass that's in the sun. Just like if we could do the calculations for the galactic center and see how far it reaches and all the mass inside the galaxy, it would be an even number. It would be a legit, okay, yeah, there's got to be this much mass in it because there's this much displacement. And beyond that, I think I'm going too long here. I'm going to say one more thing. If you're outside and you see Orion's belt and the stars, 1, 2, 3, and you look up that way, and there's like a big cluster of stars up there, that's a relief zone. Whether it forms a black hole or a baby galaxy. Yes, a relief zone can be big enough to form a baby galaxy. Look at how big our galactic center is. Look at how big that black hole is. Look at the amount of space. That could totally be a baby galaxy forming. So it's really neat stuff. I'm going to let you go with that.